to go ahead and open our book. We did lesson 11, I mean, not lesson 11, lesson 1 on Thursday, and then you had a form about it on Friday. We're going to be doing lesson 2 from our unit 1, which is on page 17, I believe. So if you, oh, not, yep, 17. So today what we're going to be talking about is scientist skills. What skills do scientists use? Find the answer to the following question in the lesson and then record the answer there. So you'll probably have to come back to this page, just like we do with the lesson vocabulary. Your question that you're going to be looking for to answer throughout the lesson is splash it, pour it, freeze it, make bubbles in it. What skills might a scientist use to test how water behaves? So you're going to answer that at some point during this lesson. What you're also going to do is you're going to list out the vocabulary words that we come across as we go through our science lesson, okay? All righty. Everyday science skills. I'm on page 18 in your science book. Please find page 18 in your science book. Everyday science skills. Do you ask questions about the world around you? If so, you use these science skills all day, every day, just like a scientist. As you read about scientists, think, hey, I can do this too. These 3 skills that are highlighted are observe, infer, and communicate. Scientists observe many things such as changes in color, temperature, and bubbling. Scientists infer how things work by thinking about their observations. A biologist may infer that the color patterns of a fish enable them to blend in and avoid predators. They also communicate. Scientists communicate or share their results and inferences with other scientists. What did you guys communicate today? So even though we haven't done any science yet today, what are some things that you communicated throughout the day? You're sharing results. What did you guys communicate about today? Owen?
Answers to Girl Can't Dance.
Answers to Girl Can't Dance. We did communicate that today. Answers to story, girl can't dance. Yes, we did communicate those responses. Answers to story, girls can't dance. All right, I'm going to go ahead and go up to the top of page 19 and start reading. Scientists use inquiry skills every day, and so do you. When you observe, you first use your 5 senses to get information. Let's say you smell cheese bread and spicy odors. You infer, I think we were having pizza for lunch today. An inference is a statement that explains an observation. I want to, even though the word inference is highlighted, I also want to underline that bit of information. An inference is a statement that explains an observation. I also want to go back to lesson vocabulary and write down inference. Inference. Okay. When you think about how things are the same and different, you compare them. For example, your family wants to adopt a new kitten. You compare different kittens, looking for one that is playful and friendly. When you decide which kitten is the best, you communicate that decision to your family. You can communicate by speaking, writing, in using pictures or models. So I'm going to underline all of that. So sometimes you might talk with one another to share your responses. You might also write or draw or show models of what you're responding to. Sometimes in science, sometimes in other things during our day. All right, so let's look at this comparison page on the right side of page 19. We have two different fishes, two different fish, I should say. Practice the skill of comparing. List the way these two fish are similar and different. So in what ways are they similar? I know we automatically want to think about ways that make them different, but I want you to tell me, how are they the same? You have this on your page 19. William, how are they the same? What is one way?
They're both fish.
They are both fish. What else? What about them, though, makes them similar as a fish? Lucas.
They live under the water. They both breathe underwater.
Breathe underwater. What else? Charlotte?
They both are very, like, in a way, like, big, like they're both the same size.
They look like the same size, but I don't know for sure because that could not be to scale, but we could put looks the same size. They both have tails. They both have that tail fin. They need that to kind of steer themselves through the water. Mason, are you writing this? They also have fins on their sides. And they both have eyes and mouths. There's a lot of similarities. And if you are familiar with breathing underwater, they both have gills. Those are things that cause them to breathe in and out, like your lungs. What differences do you see? What differences, Owen?
They're different species in fish.
Species of fish. I like that. What else? Lucas.
The puffer fish is spiky and the powder blue tang is not.
Okay. Spikes on the one fish. The other one looks pretty smooth. So I'm just going to put spikes versus smooth. What else? Kira.
One can be dangerous and the other can't.
So dangerous versus safe. What else? Charlotte?
One's like very skinny and one's very like puffy, you know, like
Skinny
ball, pretty much, like
versus puffy. Good. All right. I'm sure we can list many other things like color and size or shape, but we have to move on. So that was page 19. We need to move. We got to move on to page 20. All right, I want us to think like a scientist on page 20. Scientists use these skills every day in their investigations, find out what they are and when you might use them. So these are the different skills. We are also going to be adding some of these words to our vocabulary. So get ready to flip back and forth. Predict, Scientists use their observations and existing research to make predictions about what will happen in the future. For example, a meteorologist uses weather patterns to determine whether it will rain over the weekend. So we have the word. I'm going to flip back to the page once I go over all of the skills. They use variables. When scientists plan experiments, they think, what is the one thing that I will change? That one thing is a variable. Let's say you want to find out how cold a freezer has to be to make fruit pops. The variable that you will change in the temperature inside of the freezer. Plan and conduct investigations. Scientists plan and conduct investigations that will answer science questions. Say you want to know how salty water must be to make an egg float. First, you think about the steps you'll take to find the answer. Next, you'll gather the materials that you'll use. Then you'll test the amount of salt. Salt, for instance, makes things more able to float. Okay, that's why they're talking about that. Hypothesize. Scientists hypothesize when they think of a testable statement that tries to explain an observation. Suppose you notice that water seems to evaporate at different rates from containers with different shapes. What would you hypothesize is a cause? And finally, they draw conclusions. Scientists draw conclusions when they use evidence to evaluate a hypothesis. If you investigate how the size of a sail affects how quickly a boat moves, you might conclude that boats with larger sails move faster because larger sails collect more wind. All righty, so I'm going to go back to my page 17. There are some words that we've already gone and put down from last lesson. So we're not going to repeat investigation, hypothesize, or conclusion. We're just going to write down variable, variable, V-A-R-I-A-B-L-E, that's variable. And we also predict, P-R-E-D-I-C-T. Variable, V-A-R-I-A-B-L-E. Predict, P-R-E-D-I-C-T, predict. Okay.
What are the words again?
Variable and predict. You can flip back and forth from 20 to 17, but variable is V-A-R-I-B-L-E. Predict is P-R-E-D-I-C-T. All righty. Give me 1 second. I am looking at my GoGuardian and I see some friends who are not in our meeting. So I am going to message them. All right, 1 second. So again, you're going to get another chat. I apologize. It's just easier to type it all at once. Please join Science Zoom. All right. So you'll get a chat. That's not for you. That's for my friends who are not joining our meeting. Okay. So I am on page 21. So the circles are still there. You are a marine biologist. I want you to think about that. You study living things in the ocean. What is one investigation you might plan? What is something that you would like to test about being a marine biologist? What is something that you could do? Charlotte, what is an idea that you have?
My idea to investigate is different kinds of seaweed.
Seaweed?
I'm not sure there's different seaweed, like, because there might be different kinds of seaweed in different oceans, actually.
Okay. What is your idea, Owen?
Invent a machine to get all the trash out of the water to help.
Oh, Looking into the trash in ocean problem. See how you can solve that. Okay, predict what a marine biologist might look for on a dive. Well, I can already predict that they might look for fish. They might look for whales / dolphin. Those are not fish. They might look for coral, which are those big reefs that they can find in the ocean. They might look for shipwrecks. They might look for the trash that Owen brought up. You can list anything that you might find in the ocean, okay? We don't really have time to go over what we would put on 21, okay? Just quickly write down what you might put for what you could predict, okay? We have some more pages to write. All right, now let's look at 22. Did you know that math and science are very interconnected, okay? Using rulers and balances, putting things in order, measuring the speed of a car, making tables and graphs. Sounds like math, but it's science too. Every scientist uses math. Let's say you are a marine biologist who studies whales. You classify whales by how much they weigh or how long they are from head to tail. You put them in order when you arrange them by length from smallest to largest. You use numbers to tell how many are alive today. You use time and space relationships to investigate when and where they migrate each year. You measure how long they are and how much food they eat. You record and display the results of your investigations in writing and in tables, graphs, and maps. So math all over the place. We always talk about that, but that is how it is used in science. So let's look down all the way at the bottom where there's 3 boxes with some science / math vocabulary. Classify and order. You classify things when you put them into groups. To put things in order, you may make a list in which position matters, such as ordering bird species by how fast they fly or move. You also measure. In science and math, you measure by using tools to find length, width, and height, mass, weight, volume, and elapsed time. And you also use numbers. You use numbers when you observe by counting or measuring. You also use numbers to compare and order. And you use numbers to describe space, speed, and force. I'm going down to these bottom ones before I go back up to the top. Use time and space relationships. Well, what does that mean? Let's see. You use timing devices such as clocks and stopwatches to collect, record, and analyze data. Analyze information about time. You can predict when it will be high tide or low tide. You can also determine how the planets move in space. Record and display data. If you're just joining us, we are on page 23 in our science book. I'm sorry, guys. Record and display data. You record and analyze information using tools, including notebooks and computers. You display or show data so that it's easy to understand by making tables, graphs, or diagrams. Alrighty, let's go ahead and do the math. Looking at what is in our table. Some of the world's biggest mammals live under the ocean's waves. The table gives the names of several kinds of whales and the number that scientists estimate are alive today. We have different types of whales on the left, and we have their population on the right. Which 2 kinds of whales have the closest number alive? Which 2 whales have the closest number alive? They are the closest in number. Hank.
The Mikey and the pilot.
So which one?
It's called the MINKE, and then the pilot.
That is the one that I thought at first, but there's actually two whales that are closer in number. Scotty?
The fin whale and the humpback whale.
The fin whale is one of them. There's one that's even closer to the fin whale. Eliza?
The one that, the fin whale and the seal whale or something?
The sky whale.
Seal?
Fin
Yeah.
and sky whales. They are just 1,000 apart. How many more pilot whales are there than minke whales? How many more pilot whales are there than minke whales? William?
200,000.
200,000. Scientists estimate that there are about 360,000 sperm whales alive today. Write that number using numerals in the table. So we're just putting it in numerical format. So that's 360,000. You're filling in the table. All right, let's take a look at page 24. Critical thinking skills. Scientists in all fields use critical thinking skills to propose and examine scientific explanations and evidence related to those explanations. For example, scientists determine if an explanation is reasonable or is supported by valid data. Data collected through direct observation is called empirical evidence. Ooh, gonna underline that. Data collected through direct observation is called empirical evidence. That's a very difficult word. I wouldn't even necessarily say fourth grade word. I'd say even kind of a high school vocabulary word right there. Scientists use empirical evidence to analyze, evaluate, and critique the results of scientific investigations. To analyze is to think. To analyze is to think about all the pieces and parts that contribute to something. I like that. I'm underlining that. To evaluate, I'm going to underline. To evaluate is to examine something and decide if it has worth or value. To critique, I'm also underlining. To critique is to carefully judge something based on your knowledge, findings, and beliefs. Okay? Analyze, evaluate, critique. Let's quickly write those down on page 17. Analyze, evaluate, critique. Analyze. On page 17, we're going to write A-N-A-L-Y-Z-E. Analyze. A-N-A-L-Y-Z-E. Evaluate. E-V-A-L-U-A-T-E. Analyze, evaluate, and critique. C-R-I-T-I-Q-U-E. Again, analyze, A-N-A-L-Y-Z-E. Evaluate, E-V-A-L-U-A-T-E. Critique. C-R-I-T-I-Q-U-E. All right. Going back to my page. All right, really quickly, logical reasoning. When you use critical thinking, you also use logic. Logic requires you to use reason and order to figure out if something makes sense. When you use logical reasoning, you do not include any emotions or opinions. When you use logical reasoning, you do not include your emotions or opinions. Remember to stay on mute, guys. Scientists in all fields use logical reasoning to draw conclusions based on evidence. Use empirical evidence. Careful observations and measurements are empirical evidence. Observations that include opinions are not. For example, recording the temperature of a mixture is empirical evidence. However, saying the mixture feels warm is an opinion. When you analyze, evaluate, and critique an explanation, you see if it is based on empirical evidence. Let's go up to experimental testing. Scientists perform an experiment to test a hypothesis. We talked about that in lesson 1. These experiments can be conducted in a laboratory or outdoors. Some scientific explanations are based on evidence from experiments. For example, suppose a scientist wants to find out how quickly Arctic ice freezes and thaws. He would design an experiment to test a specific hypothesis related to this question. He would then analyze the data he collected in order to help answer his question. Alternative explanations. When you analyze, evaluate, and critique a scientific investigation, an important question to ask is, might there be another possible explanation for this data? This would be an alternative explanation. For example, you might conclude from an investigation that bees that pollinate red flowers produce more honey than bees that pollinate yellow flowers. Other factors may account for the difference in honey production. Always consider alternatives when you analyze, evaluate, please stay on mute, and critique a scientific explanation. Last circle, observational testing. It is not always possible to answer a question by conducting an experiment. For example, astronomers study objects in space, such as planets and stars. Since these objects are very far away, the only way to study them is to observe their patterns. Scientists use observational testing to compare their patterns and draw conclusions. Alternative explanations. Milo concluded that the number of chirps crickets make each minute is based on when the sun sets at night. Suggests an alternative explanation for the number of times crickets chirp. So basically, do you think that a cricket chirps because the sun is setting at night? What do you think another explanation could be for why a cricket is chirping? I don't know why crickets chirps. You tell me why you think. Eliza, why do you think a cricket might chirp other than sunset?
I think it's because I think it's because that one of the crickets they're communicating by.
That is exactly what I was thinking. Crickets are communicating. That is exactly, they're talking, they're communicating, they're saying something to another. One more, William.
Maybe they want to make predators think that there's birds, so they either fly up or just leave because they can't get up in the trees.
Okay, so confuse the pet predators. confuses the predators. So William's saying maybe to act like a bird. They're chirping. Either one works. If you have a different one, that's great. I got to move on. We're kind of running behind. Tomorrow, I just want to point out what you are going to be doing. Tomorrow, there is going to be a Google form that you fill out. And you are going to be looking at this brain check, filling in the space with switching the red words around until each statement about inquiry skills makes sense. Okay, so you're going to be switching the word that goes on the line. And then I'm going to have you answer some of the questions. I'm going to look through and pick out some of the questions that I think will really make sense for you. So as long as you sat and you listened to our whole Zoom, you'll kind of know what some of those answers are. I also am going to post the Zoom once we are finished with science today and math, and that will be posted in case you would like to rewatch. Also in Google Classroom, not yet, but it will be there. It'll be posted. It'll say science 1-19-2021. It's going to have the video, and it's going to say what pages we read. If you are in this Zoom, you can just check off that you watched it. If you did not attend the Zoom, you're going to have to, or the entire Zoom, you're going to have to watch up until you joined, okay? Because I don't want you missing anything that we learned together, okay? So be on the lookout. Probably around 2:15, the video and the assignment will be posted. And if you were here in the Zoom again, you will just click that